This question is about sulfuric acid and its salts. Draw the displayed, so we make sure we must show every atom and every bond, formula of a molecule of sulfuric acid. So we need to remember that in sulfuric acid that the S is at the centre. You might remember this from when you're drawing the mechanism with alkenes, that it has two double bond O's and two single bonded O's that are attached to hydrogens. Make sure you show every atom and every bond. If you work out the oxidation state of the sulfur, you'll see it's +6, and that might help you remember to draw 6 bonds coming from the sulfur, 2 doubles, 2 singles. In aqueous solution, sulfuric acid acts as a strong acid. So it's telling you it dissociates to form these two ions. It then tells you that the hydrogen sulfate ion is a weak acid, and it tells you what it dissociates to give, and it wants you to give equations for each stage. Now the trick here is that strong acids fully, and they've given you the clue in the question with the names, strong acids fully ionize. So we need to draw a one directional arrow. But then it says that the HSO4 is a weak acid and they only partially ionize. So we need to draw a reversible arrow to give us the second hydrogen ion and a sulfate ion. The next part of the question is asking us to describe how you would make a solution of 250 centimetres cubed of an accurately measured mass. So it's a standard solution and it's accurately measured mass, so that's weighing by difference. So let's find the mass of a weighing boat and the sodium hydrogen sulfate. I'm going to tip the sodium hydrogen sulfate into a beaker, reweigh the weighing boat, and then by difference find the mass of the sodium hydrogen sulfate. So weighing by difference. You're then going to dissolve the sodium hydrogen sulfate in the beaker using deionized or distilled water. And then we're going to transfer to a 250 centimetre cubed, because that's the amount we want to make, volumetric flask, including all the washings. So that's where you rinse the beaker into the volumetric flask to ensure that all the dissolved solid ends up into the flask. Then we're going to make the flask up to the mark with deionized or distilled water. And then sort of add a stopper and invert several times to mix thoroughly. Then it says a solution containing 605 milligrams, so that would be 0.605 grams, sodium hydrogen sulfate in 100 centimetres cubed of solution has a pH of 1.72. So the first thing I'm going to do is work out the hydrogen ion concentration from the pH. So on my calculator, 10 to the minus 1.72, 0.0191. I'm going to work out how much the number of moles of sodium hydrogen sulfate by doing the mass, 0.605, divided by the MR, which I'm going to add up, 120.1. 5.04 times 10 to the minus 3. I'm going to turn that into a concentration by dividing by volume. making sure that volume goes into decimeters cubed. Okay, so I've got the concentration. I'm going to remember that for a weak acid, Ka equals H plus, go back to that equation that you just wrote when the HSO4 minus ion in this NaHSO4 dissociates, you get these two ions, and that's our full formula. Okay, now because it's a weak acid, we can say that the top line is the same as H plus squared. So we can put in our numbers. Oops, sorry, that bottom line is incorrect. So 0.0191 squared over 5.04 times 10 to the minus 2, or 0.0504. And that's giving me 0.0191 squared, 7.24 times 10 to the minus 3. Okay, so I'm going to put that on my answer line. I think if you keep all the numbers in your calculator, you might get a slightly different answer. The units of Ka, concentration squared over concentration, so they are the units of concentration. Now, on the bottom line here, because you could have done a sort of subtraction, the amount of HSO4 minus that got used up by subtracting the 0.0191 away from the 5.04 times 10 to the minus 2, but you didn't need to. Some sodium sulfate is dissolved in a sample of a solution, the solution from the previous part. Why does this increase the pH? That means becomes less acidic. So sodium sulfate contains SO4 minus ions. So the SO4 minus ions react with H plus. So if you think back to the equation that you wrote, HSO4 minus in equilibrium with H plus and SO4 minus, the SO4 minus ions react with H plus, the equilibrium shifts left, concentration of H plus decreases because you've used it up, so pH increases.